Example 8.7. Find the de Broglie wavelength associated with an alpha particle which is accelerated to a potential difference of 400 volt. Given that the mass of the proton is 1.67 into 10 raised to minus 27 kg. What is given here is the potential difference is given, that is the value of V is given as 400 volt, and the mass of proton is 1.67 into 10 raised to 27 kilogram. Now what is asked? The de Broglie wavelength associated with alpha particle. So the formula for the de Broglie wavelength is h by root of 2m_qv. Okay, here the mass of alpha particle is equal to 4 times mass of proton. That is, charge of alpha particle is equal to 2 times charge of electron. Okay, so I can write lambda is equal to h by root of 2 into 4 times mass of proton into 2 times charge of electrons into V. Okay, so I'll write it like this. So lambda is equal to, I'll substitute the value, 6.626 into 10 raised to minus 34 divided by root of 2 into 4 into 1.67 into 10 raised to minus 27 into 2 into 1.6 into 10 raised to minus 19 into, here it is 400. Okay, now here we can take here 2, 4 and another 4 is there. So I can take in the denominator from the root 4 outside, and also I can take 400 is 20, root 400 is 20. Now here it is 27 plus 19, that is 46. So I can take it as 10 raised to minus 23 outside. What are the remaining things? That is 1.67 into 1.6. Now you can go for doing it. 6.626 into 10 raised to minus 34 divided by 4 into 20 into 10 raised to minus 23 to root of, this multiplication value is 2.672. Okay, if you find out the root, 4 into 20 into 10 raised to minus 23 into 1.634 root value is. If you multiply the denominator values, you will be getting is 130.77 into 10 raised to minus 23. Now if you divide this by this, you will be getting it as 0.05066 into 10 raised to minus 11, you will get it. So this can be written in Armstrong as 0.005066 into 10 raised to minus 10. So the lambda value here it is 0.00507 Armstrong.